All right, guys, we're getting into chapter 3 now, which deals with graphing linear equations, and that's what section 1 is. And so let's get started. So previously you represented relationships among quantities using equations, and now we're going to identify linear equations, intercepts, and zeros in this first video. And then the next one, we're going to talk a little bit about how to graph linear equations. So here's your vocab: linear equations, standard form, constant, x-intercept, and y-intercept. So let's jump in. Linear equations in standard form. A linear equation is an equation that forms a line when it's graphed. You can even see the word line in linear. I know the word ear is in there, but that's not really pertaining to what we're doing here. So linear equations are often written in the form ax plus by equals c. That is called standard form of a linear equation. In this equation, c is called the constant. It doesn't have a variable next to it, or just the number. And ax and by are the variable terms. Notice a couple things. The x and y go in alphabetical order, and so do the a and b and c. And it's ax plus by equals c. Now, I know that a, b, and c are numbers, or excuse me, letters, and so are x and y. However, a, b, and c stand for the numbers that could be there, okay? And x and y are the variables that make up the equation. So standard form of an equation is ax plus by equals c, where a is greater than or equal to 0, and a and b are both not 0. Now what that means is that a could be 0 or b could be 0 in the equation. In other words, there wouldn't be an x or there wouldn't be a y, but both of them can't be 0 at the same time. If they were, you wouldn't have an x or a y, and there'd be no variable in the equation. And a, b, and c are integers with a greatest common factor of 1. So for example, 3x plus 2y equals 5. That's a linear equation because you have a equals 3, b equals 2, and c equals 5. If you have x equals negative 7, in that equation, that's fine, because a would be 1, that's the number that's understood to be in front of x. B would be 0, because there's no y term, so that means b would have to be 0, and c would equal negative 7. Likewise, if you had, say, y equals 6, in this case, there's no x term, so the a equals 0. The b equals the coefficient of the y, in other words, what's in front of the y, it's understood to be a 1, and c would be 6. Okay, so those are basically the three types of linear equations that could come up in standard form, where you have x and y, where you have just x, or you have just y. All three cases, they form a linear equation. So determine whether each equation is a linear equation and write it in standard form. So here we have y equals 4 minus 3x. Well, to rewrite the equation so it appears in standard form, we need the x's on the left side with the y. So we're going to add 3x to both sides, and you get 3x plus y equals 4. Is it in the form ax plus by equals c? Yes. Is the a value greater than or equal to 0? Yes. Are a, b, and c integers with the greatest common factor of 1? Yes. In other words, if there's a greatest common factor of 1 between all three numbers, that means there's no number that could evenly divide into all three of them. So think of it like that. Okay? The equation is now in standard form, where a is 3, b is 1, c is 4, and this is a linear equation because it fits the standard form. How about this one? 6x minus xy equals 4. All right, since the xy term has two variables, the equation cannot be written in the form ax plus by equals c. Therefore, it's not a linear equation. I will also add this. Okay, it's not going to be a linear equation if you're like dividing by x or dividing by y, or you have exponents on the x or the y, or stuff like that. Or if you have a square root in the problem, it has to be just an x and or just a y, okay, with a number in front of them. All right, here's a couple for you to try. Go ahead and pause the video and hit play when you're ready. All right, we're back. So we have to determine if the first one is in standard form. Now remember, we want ax plus by equals c, where a, b, and c are integers. All right, so in this case, 1a looks like it could be a linear equation. It's just missing the x, which would mean a is 0, which is fine. But 1/3 is not an integer. So what we'd have to do is multiply 3 times both sides, and you get y equals -3. Okay, so this is a linear equation. It's in standard form now, and the value of a would be 0, b would be 1, and c would be -3. Okay, now let's look at b. Okay, so we have to get the x terms on the same side. You might already be able to see what's going to happen. So if I subtract x squared from both sides, I would get -x squared. Now be careful here. The y itself is positive, so I would write plus y equals -4. Now remember, the a term has to be positive. In other words, the number in front of the x has to be positive. So I would divide both sides by -1, and you get x squared minus y equals 4. Now this looks like it could be a linear equation in standard form. However, remember I said you have to have just x and or just y equals a number. Well, here I have x squared. This exponent destroys it from being a linear equation. It'd be similar to, so that's not a linear equation. If I had, say, 1 over x plus 3y equals -17. It looks like there's just an x and just a y, and the value of a looks like it would be 1, b looks like it would be 3, c looks like it might be -17. But the problem there is that you're dividing by x. Okay, it has to be just some number times x plus some number times y equals another number. Okay, if the x or y are missing, that's fine. That's fine. Okay? All right, a linear equation can be represented on a coordinate graph. The x-coordinate of the point at which the graph crosses the x-axis is an x-intercept. It intersects, kind of think of it like that, it intersects the x-axis, so that's called the x-intercept. And the y-coordinate of a point which the graph crosses the y-axis is called, guess what, the y-intercept. So the graph of a linear equation has at most one x-intercept and one y-intercept, unless it's the equation x equals 0 or y equals 0, in which case every number is a y-intercept or an x-intercept respectively. And we'll talk about what that means in a minute there. Okay, so here's just a graph of a line. Notice that the y-intercept is 0, 2, because the x-coordinate is 0, which means to get to that point, you just go up 2 and it's still on the y-axis. If you move left or right at all, you won't be on the x-axis. So the only way you can get a y-intercept is if the x-coordinate is 0. Okay. Likewise, with the x-intercept, notice that the coordinate is -4, 0, which means you move 4 units to the left and stay there. Now, the y-coordinate of all x-intercepts has to be 0, because if it wasn't, you would move up or down, and therefore you wouldn't be on the x-axis anymore. Okay, so let's find the x and y intercepts of the line graphed at the right. So I can identify them right here and here. Okay, they're the points where the graph crosses the x or y axis. Now here, this crosses the x-axis at 20, so that's the point 20, 0. And since the 20 is the x number, that's the x-intercept is another way to think of it. This one, the coordinate would be 0, 30. Remember, you always move in the x direction first, and since this point, to get to this point, you don't go left or right, you just go straight up. So it's the y-coordinate is 30. So that's the y-intercept, and this is the x-intercept. So the x-intercept 0, that's not right. The x-intercept's 20 and the y-intercept's 30. That looks to be correct. The x-intercept's 20, that's right, but the y-intercept is not 0, and the x-intercept is 30, y-intercept's 20, those have those backwards. So the correct choice is B. Okay? All right, so I kind of already explained this. Forgot to click through it. So the answer is B, yeah. All right, here's a couple for you to try. Go ahead, or actually one for you to try. Go ahead and pause the video and hit play when you're ready. All right, we're back. So you can see that the graph crosses the y-axis here at 150. And notice the arrow's pointing straight to the right and it's a horizontal line. Is it ever going to cross, like go whoop, come down here and cross? No, it's not going to do that. So since it crosses here at 150, which axis is that? Right, it's the y-axis. So that would be the point 0, 150. So 150 is the y-intercept. And it doesn't cross the x-axis, so there is no x-intercept. So that would be choice J. No x-intercept and a y-intercept is 150. And I think this is a good place to bring up an important point. Okay? The only way that you will not have an x-intercept is if your graph is a horizontal line like this, because it runs parallel to the x-axis and will never cross it. Now, the one exception to that is if your line is a horizontal line and it lines right up with the x-axis like this, okay? In which case, every point would be an x-intercept because it touches the x-axis at every point. Likewise, every vertical line, okay, so this is the x-axis and this is the y-axis because we got a lot of lines going here. Every vertical line is going to have only an x-intercept and no y-intercept. And again, the only exception to that is a vertical line that lines right up with the y-axis. In that case, every point is going to be a y-intercept because it's right on the y-axis. Now, if you have any other kind of line that has any diagonalness to it, eventually it's going to have an x or a y-intercept. It doesn't matter where you place the line or how steep or how flat you make the line, eventually it's going to have an x and a y-intercept if it's some kind of diagonal line. Okie doke. All right, so a swimming pool is being drained at a rate of 720 gallons per hour. The table shows the function relating the volume of water in a pool at the time in hours the pool has been draining. So time from 0 all the way up to 14. 0, 2, 6, 10, 12, 14. Notice it doesn't just go by twos, it kind of skips a little bit, and the amount of water in the pool. I will say, notice that the amount of water in the pool is going down, which makes sense because they're draining out the water. So kind of as time goes by or as time increases, the amount of water decreases. Okay, find the x and y intercepts of the graph. Well, the x-intercept would be 14 because that's the value of x when y is 0. And the y-intercept is 10,080, and that's the value of y when x is 0. Remember what I said, all x-intercepts have a y-coordinate of 0, and all y-intercepts have an x-coordinate of 0. So describe in what the intercepts mean in this situation. So the intercept of 14 means that after 14 hours, the water of the pool has a volume of 0 gallons, or basically the pool is completely drained. Okay, the y-intercept 10,080 means the pool contains 10,080 gallons of water at time 0 before it started to drain. In other words, when the pool was full, there was 10,080 gallons of water in the pool. And so if we graph these points on a graph, and notice we made the h-axis, or what's like the x-axis, go by twos, and the y-axis go by 2,000s. All right, so we could fit it all in. So you can see how it goes down here. All right, so here's one for you to try. Go ahead and pause the video and hit play when you're ready. All right, we're back. So the table shows the function relating the distance to an amusement park in miles and time in hours the Torres family has driven. Find the x and y intercept, describe what they mean. Okay, so the x-intercept, I'm still on green from before, is 4. The y-intercept is 248. Now, how did I know it was x and y and not reversed? Well, usually in a table, the x is here and the y is here. Also, the independent variable is x and the dependent variable is y. And typically, your distance depends on how long the time that you've been driving. Okay, so the x-intercept means that the Torres family arrived at the amusement park 4 hours after 4 hours of driving. The y-intercept means that the Torres family is 248 miles from the amusement park, or as soon as they started, they had 248 miles to drive to get to the amusement park. That's the y-intercept. Okie doke. All right, guys, that's it for this video. Please stay tuned and check out the next one when we talk about how to graph linear equations. We'll see you there.